So hello everyone, good morning. So I think my voice is audible and my video is clear, right? So just a minute, I'll just check everything's fine. Check everything's okay. So in the previous class, we discussed about limit, right? So we discussed about limit. So even though f is not defined at that point, we can talk about limit at that point. So limit is nothing but at the point function is not defined. So we are attacking the point from the right and from the left. You see where f is approaching. If your LHL and RHL both are equal, then we say limit exists at that point. If not, limit does not exist, right? So there are many limiting techniques. So one is by standard formula, sin f of x by f of x, tan f of x by f of x, e power f of x minus 1 by f of x, log of 1 plus f of x by f of x, right? So all this we have seen yesterday, and then we can also evaluate limit using a L'Hopital rule, right? So evaluation of limits using standard formulas and L'Hopital rule that we discussed, and then after that how to find the limit when the function is tending to 1 power infinity. So f of x power g of x, when you apply the limit, it is of the form 1 power infinity. So how to find limits, that we have seen. After that, how to find the unknowns, the question if the limiting value is given, right? That we have seen. And then in the group I have sent you an assignment problem based on limits. So today what we're going to do is I'm going to discuss about continuity, right? Continuous function. So I'm just extending the idea of limits, right? I'm just extending the idea of limit. So first what we'll do is we will define what is meant by continuity at a point. Continuity at a point. So continuity at a point. So we will define what is meant by continuity at a point first. Fine. Based on okay. So continuity at a point. See, very simple. If you can draw a graph of the function, you can draw the graph of the function without lifting the hand. If you can draw the graph without lifting the hand, then we say that function is a continuous function. Right? The function is a continuous function. If I can draw without lifting the hand, then we say that function is a continuous function. Now, what we will do is we will define what is meant by continuous at a point. Continuity at a point. At a point, whether function is continuous or not. Right? So let us say we have a function. Let us say we have a function y is equal to f of x. Right? Y is equal to f of x, and we see that this function is very smooth and I can draw without lifting the hand. Now I'm going to check whether at x is equal to a, let us take a point a. I'm going to check whether at this point whether the function is continuous or not. So this value is my function value, which is nothing but f of a, right? This value is f of a. Now I'm asking you whether the function is continuous at x is equal to a, right? That means if I can pass through this region, if I can pass through this region without lifting the hand, if I can pass through the neighborhood of this region without lifting the hand, then we say the function is continuous at that point, right? So if I can pass through this region without lifting the hand, then at x is equal to a, there is no hole, right? See, when a function is not continuous, there has to be some hole. If there is some hole, means what you cannot do? You cannot pass through this region, right? You cannot pass through this region. So that means from year to year, you take a small neighborhood. That neighborhood you have to pass, right? If it happens, then I can pass through this region, right? So how to check a continuity at a point? How to check a continuity at a point? So very simple. So what you do is I'm checking whether a function is continuous or not at a point A. So if I can pass through this region without lifting the hand, then we say this function is continuous at this point. So how to derive that mathematically? Very simple. You find your RHL You find your right hand limit for the function at x is equal to a. Now right hand limit will come very closer to this point, right? Let us say this point is your f of a. This is your f of a. Now your right hand, if you find right hand limit, we are approaching a from the right, so the graph will approach this point, and similarly you find the left hand limit at x is equal to a, then you will approach this point, right? If both, just see me, if your LHL, RHL both are approaching same point and both are equal to f of a, if this happens, it will stick together. Yes or no? Your LHL, RHL both are approaching same point and both are equal to f of a. That means there is no gap here, right? You can be able to visualize, right? So at x is equal to a, the function is continuous or not, we are checking. So we are finding LHL, we are finding RHL, both will approach one point. If both are approaching a point f of a, that means it will stick together. That means you see this as a bridge. Your LHL is coming, RHL is coming, and both are sticking to f of a. That means this is a continuous region, right? This is a continuous region. So very simple, we say f is continuous at a point. We are talking about continuity at a point. At a point x is equal to a, if your LHL and your RHL and f of a both all are equal. Now what is the formula for LHL? Limit s tending to 0 f of a minus h. And what is the formula for RHL? A formula for RHL will be limit s tending to 0 f of a plus h, and both has to be equal to f of a. If these two are equal, then we say limit exists at a, right? If these two are equal, then we say limit exists. If limit exists, I can write this as limit x tending to a f of x exists, and that should be equal to f of a. So very simple, limiting value is equal to function value. That's it. We are finding limiting value of the function when x is tending to a. If that is equal to the function value, then we say f is continuous at a point. Right? Very simple. If you want to check continuity at a point, you know how to find limit. You see whether it is equal to f of a. That's it. If it is these two are equal, then we say it is continuous at that point. If it is continuous at each of its point, if it is continuous at each of its point, if it is continuous at each of its point, that means whatever point you take, your f of a and your LHL, RHL are equal. That means what? You can pass through this whole graph without lifting the hand, right? If it is continuous at each of its point, then we say your function f is a continuous function. So continuous function means it has to be continuous at each of its point. What you take any point in that, you take any point x is equal to a. For that point, your LHL, RHL, f of a, all three has to be equal. If that happens, then we say f is continuous at that point. If it is not happening, then we say f is discontinuous at x equal to a. Right? If not, if this is not happen, we say f is discontinuous. Right? We say f is discontinuous at x is equal to a. Right? Discontinuous at x is equal to a. So we'll move on to problems directly. So if I want to check continuity at a point A, you find your LHL, you find your RHL, and you find f of a. You see whether all are equal. If that happens, then we say your f is continuous at that point. Right? Okay. Directly, we will solve some problems. Problem 1, f of x equal to 2 by x of sine of k1 plus 1x plus sine of k2 minus 1x. If x is less than 0, it is 4 when x is 0. It is 2 by x log of 2 plus k1x divided by 2 plus k2x when x is greater than 0. If f is continuous at x is equal to 0, find k1 and k2. So here k1, k2 are unknown. It is given that it is given that your f is continuous at 0. Right? It is given that your f is continuous at 0. So since f is continuous at x is equal to 0, your LHL at 0, RHL at 0, and the function value at 0, all are equal, right? So first what we will do is we will find LHL. That is, we need to find limit extending to 0 minus. See, I'm not using the definition of LHL. Limit extending to 0 f of a minus h. We don't need that. So what I'm doing is I'm finding left hand limit of the function, right? Limit extending to 0 minus of f of x. If 0 minus, what is your function? This is your function, right? So limit of this function when x is tending to 0 will be your left hand limit. Limit of this function when x is tending to 0 will be your right hand limit, because 0 left, we are approaching 0 from the left. So from the left, my function is what? This is your function, because when x is less than 0, the function is this. So limit extending to 0 minus. So we have limit extend. So 0 minus stands for I'm applying 0 from the left. Don't think it is sine, right? 0 minus. So it is 2 by x of sine of k1 plus 1x. What we will do? Can we apply standard formula? We need to find limit extending to 0 for this. So what I'm doing is I'm multiplying and dividing by k1 plus 1x, k1 plus 1x, because we know sine f of x by f of x is 1, plus sine of k2 minus 1x. So here you multiply and divide by k2 minus 1 times x, k2 minus 1 times x. So we know sine f of x by f of x is 1, provided your f of x tends to 0 as x tends to a. So this will be limit extending to 0 minus. See, this 0 minus is nothing but we are approaching this from the left. Anyway, you will be substituting limit 0 only, right? So this will be what this will happen? This will be 1 sine f of x by f of x. This will be 1 again. So you'll be having k1 plus 1x, k2 minus 1x. So that's it. So x will get cancelled. So 2 times of k1 plus k2. So this is your x will get cancelled, plus 1 minus 1 will get cancelled. So 2 times of k1 plus k2 is your LHL, right? Now we will find RHL. So RHL is I'm approaching 0 from the right. So from the right, what is my function? This is my function. When x is greater than 0, right means 0.1 to the right of 0. So my output will be here. So 2 by x of log of 2 plus k1x divided by 2 plus k2x, right? See, we know that limit extending to a log of 1 plus f of x by f of x is equal to 1, provided your f of x tends to 0 as x tends to a. So what we will do is this will be limit extending to 0 plus 2 by x of. So what I will do is I'll just take 2 outside here, 1 plus k1x by 2. Here I'll take 2 outside, 1 plus k2x by 2. So 2 will get cancelled. This will be limit extending to 0 plus 2 by x of. So log a by b. So log a minus log b. So log 1 plus f of x. So my f of x is k1x by 2. So you multiply and divide by k1x by 2, k1x by 2. Log of 1 plus f of x. So f of x is k1x by 2, and that will tend to 0 when x is tending to a, plus sorry, minus log a by b. So log a minus log b. So minus log of 1 plus k2 x by 2. So we multiply and divide by. So multiply and divide by k2 x by 2. K2 x by 2. This will be 1. This will be 1. So log 1 plus f of x by f of x, that will be equal to 1. So this will be limit extending to 0 plus of 2 by x of k1 x by 2 minus k2 x by 2. So x will get cancelled, 2 will get cancelled. So k1 minus k2 is your RHL. And what is the function value at 0? It is given, right? At x is equal to 0, it takes 4. It takes 4. Function value at 0 is 4. So since f is continuous, at x equal to 0, your LHL, RHL and your function value all are equal. So your LHL is equal to RHL is equal to function value at 0, all are equal. So my LHL is 2 times of k1 plus k2 and your RHL is k1 minus k2 and the function value at 0 is 4. Now solve for k1 and k2. So we have k1 minus k2 is 4 and we have k1 plus k2 is 2. So 2k1 is 6, k1 is 3. If k1 is 3, k2 is k1 minus 4. So minus 1 is your k2. That's it. So your k1 is 3 and k2 is minus 1. Right? Very simple problem. See, that's what I'm saying. If you are strong in limits, continuity is very, very, very simple. The only thing is they will say it is continuous at some point. To the left of that point, they will give some function. To the right of the point, they will give some function. At that point, they will give the function value. So just find limit for this function, limit for this function, and this function. If all three are equal, it is continuous. But it is when it is continuous, so with that we are finding the unknowns k1 and k2. Right? Is it clear? Clear, right? For watching. Okay. So we'll move on to problem number 2. For a comma b greater than 0, let us define f of x as tan of a plus 1x plus b tan x divided by x when x is less than 0. It takes 3 when x is equal to 0. It takes the value root of ax plus b square x square minus root of ax divided by b root a x root x when x is greater than 0 is continuous at x equal to 0. Find the value of a and b. So for what value of a and b, it is continuous. So since it is continuous at 0, your LHL, RHL and function value, all three are equal, right? All three are equal. So first what we will do is, we will find LHL. So limit extending to 0 minus of f of x. So limit extending to 0 minus of 0 left hand side. Your function is tan of a plus 1x. So we have tan f of x. So you multiply and divide by a plus 1x, a plus 1x. And then we have b tan x, you multiply and divide by x. We know tan f of x by f of x is 1. So this reduces to limit extending to 0 minus, and then we have whole divided by 3, whole divided by x. So this reduces to, this will be 1, right? So we will be having a plus 1 times x plus bx divided by x. So a plus b plus 1 is your LHL. Now we will find RHL. So RHL is limit extending to 0 plus of root of AX plus B square x square minus root of AX divided by B root A x root x. So we'll take one x outside and then we'll cancel root x. So what we'll do is you take one x outside here and you take this x outside from the root. So root x you take outside. So it will be, if you take one x outside, you will have a plus b square x minus root a divided by b root a root x into x. So these two will get cancelled. So this 1 by b root a is constant. So I can work with limit extending to 0 plus r square root of a plus b square x minus root a divided by x. So we need to take conjugate, right? So whenever you have under root, you take conjugate. So root of a plus b square x plus root a divided by root of a plus b square x plus root a. So when you apply the limit, numerator will be a plus b, a minus b, right? Which is a square minus b square. And when you apply the limit here, this is a finite non-zero number, right? So whenever you are doing rationalization, when you apply limit for this, this will become, when you apply the limit, we have product of functions, you apply the limit separately. So here when x is 0, this will be root a plus root a. So 2 root a. So you take this 2 root a, 1 by 2 root a outside because 2 root a is below. So you take 1 by 2 root a outside and we will be having x alone. So this a will get cancelled, x will get cancelled. So 1 by 2b root a into root a is a, and here we will have only b square. So b by 2a is your RHL. Now what it is given that the function value at 0 is 3, right? So since f is continuous, at x equal to 0, your LHL, RHL function value all are equal. So my LHL is a plus b plus 1, RHL is b by 2a, and the function value at 0 is 3. So solve for this. So we have a plus b is equal to 2, right? A plus b plus 1 is 3. That means a plus b is equal to 2. And then we have b minus 6a is equal to 0. Now you subtract this. So these two will get cancelled. So a plus 6a. So 7a is 2. So a is 7 by 2. If a is 7 by 2, you know b is 6 times a. 6 times 7 by 2. So 2 ones are, 2 threes are. So b is 21. Right? So b is 21. A is 7 by 2. So we'll move on to third problem. F of x equal to 1 minus cos 2x divided by x square when x is less than 0. It takes the value alpha when x is equal to 0. It takes the value beta times root of 1 minus cos x divided by x when x is greater than 0. Is continuous at x equal to 0. Find alpha and beta, right? Find alpha and beta. So it is continuous at 0. So my LHL at 0, RHL at 0, function value all are equal. So limit extending to 0 minus of f of x. I'm finding LHL. This is limit extending to 0 minus of 1 minus cos 2x by x square. So this is, we know 1 minus cos x is 2 sin square x by 2. 1 minus cos x is 2 sin square x by 2. Replace x by 2x. It will be 2 sin square x by x square, which is 2, right? Because sin square x by x square is 1. You find RHL now. So RHL is limit extending to 0 plus of f of x. So limit extending to 0 plus of beta times root of 1 minus cos x by x will be limit extending to 0 beta times root of, so 1 minus cos x is 2 sin square x by 2 by x. Now you take beta root 2 outside, you will be having sin x by 2 by x. Now you multiply and divide by x by 2 x by 2. So this will become 1. This x will get cancelled. So beta root 2 by 2. Beta root 2 by 2. Beta root 2 by 2 is your RHL, and the function value at 0 is alpha. So since f is continuous, at x equal to 0, so your LHL is equal to RHL is equal to function value. So my LHL is 2, RHL is beta root 2 by 2, and function value is alpha. That means alpha value is 2, right? Alpha value is 2, beta value is 4 by root 2. 4 by root 2. So these are the value of alpha and beta. On to problem number 4. F of x equal to just a minute. F of x equal to 1 by x of log of 1 plus so it is given that it is continuous at 0, right? Find the value of, see my voice is clear or some side disturbance is coming? Some sound is coming, is there or not? Because outside they are making saw. My voice is clear only, right? Is there any side disturbances? Okay. So we will find LHL. So limit extending to 0 minus of f of x. This limit extending to 0 minus of 1 by x of. So I'll make use of log a by b. So here we have log of 1 plus f of x. So you multiply and divide by x by a, x by a. Here you multiply and divide by minus x by b, minus x by b. Log of 1 plus f of x. See, in the previous question, you should have asked why we are doing log a by b, and then we are making standard formula. You may think like why we can't do like this. Let us write this as log of 2 plus k1x minus log of 2 plus k2x, and this can be done as log of 1 plus k1x. Now you can treat this as f of x, right? Log of 1 plus f of x. But here the thing is, f of x is, and here the thing is, my f of x is not tending to 0 if you do like this. If you do like 1, if you write 2 as 1 plus k1x, now you can treat this as f of x, log of 1 plus f of x, but your f of x is not tending to 0 when x is tending to 0, it is tending to 1, right? That is why we are not doing like this. That is why what we are doing is, in order to make your f of x to tend to 0, you have to take 2 outside and then cancel 2 and then make use of log a minus log b. Now this again here also log of 1 plus f of x, log of 1 plus f of x plus only. So f of x is minus xy minus xy. This will be limit x tending to 0, 1 by x half. This x by a will become 1 plus x by b. So x will get cancelled. So 1 by a plus 1 by b is your LHL. 1 by a plus 1 by b is your LHL. Now you find RHL, limit x tending to 0 plus of f of x. So limit x tending to 0 plus of f of x. I can write this as cos 2x, right? Cos square x minus sin square x is cos 2x minus 1 divided by root of x square plus 1 minus 1. So you will make a conjugate. So whenever you have under root, you should always make conjugate. So root of x square plus 1 divided by root of x square plus 1 plus 1. So whenever this can be a plus b, a minus b, and this is a finite non-zero number when you apply the limit. Always it should be finite non-zero number. When you do a plus b, a minus b, the remaining part you added, no, that is always a non-zero number. So when you apply the limit, it will be 0 plus 1 is 1, 1 plus 1 is 2. I'm taking 2 outside. So limit x tending to 0 plus cos 2x minus 1 by a plus b, a minus b. So a square minus b square. 1 will get cancelled. Let us take minus outside. This 1 minus cos 2x by x square. So 1 minus cos x, 2 sin square x by 2. So 1 minus cos 2x is 1 minus cos 2x is 2 sin square x by x square. So sin square x by x square will be 1. So minus 4 is your RHL. Minus 4 is your RHL. Now what is function value at 0? It is continuous at 0 and function value at 0 is k. So since f is continuous at x equal to 0, my LHL is 1 by a plus 1 by b and RHL is minus 4 and the function value is k, right? So this is 1 by a plus 1 by b is equal to minus 4 by k is equal to 1. So you bring this term here. So 1 by a plus 1 by b plus 4 by k is equal to 1. That is what we are going to find, right? So we need to find the value of 1 by a plus 1 by b plus 4 by k. So it will be 1, right? It will be 1. We'll move on to fifth problem. So problem 5, f of x is equal to 72 power x minus 9 power x minus 8 power x plus 1 divided by root 2 minus root of 1 plus cos x. When x is not equal to 0 and it takes a value of a times log e2 log e3 when x is equal to 0 is continuous at x equal to 0, find a. See here, when x is not equal to 0, the function takes this value. That means 0 minus 0 plus both are same function. Yes or no? So in the previous all four problems, they are given to the left of 0 one function, to the right of 0 one more function. At 0, they are given the value. But here you see that when x is not equal to 0 itself, it takes this value. So 0 plus 0 minus both are same function only. So directly I will find limit extending to 0 of f of x. Is it clear what it is already continuous, so limit exists. It is given continuous. That means limit should exist and limit should also equal to the function value. So since limit exists, your LHL RHL has to be equal. So you don't need to find 0 minus 0 plus, because 0 minus 0 plus are same function. When x is not equal to 0, it takes this value. 0 plus means what? 0.000001. This is your function, output value. 0 minus means to the left of 0, minus 0.00001. Again, this will be the output. So I'm directly finding, you just find limit for this function. When if they are not given to the left of 0, to the right of 0, different function means you do separately LHL, RHL. If x is not equal to 0, only one function means you directly do only one limit. The limit extending to 0 of 72 power x minus 9 power x minus 8 power x 1 divided by root 2 minus root of, so 1 plus cos x is 2 cos square x by 2. So we know the standard formula, right? This we haven't used it, but I have given you limit extending to a p power f of x minus 1 by f of x. This is log p, log ep, provided your f of x tends to 0 as x tends to a. Right? This we discussed in the previous class. So what we will do is we will write this 72 power x as 8 power x 9 power x, and we have 9 power x minus 8 power x plus 1 divided by root 2 minus root 2, so cos x by 2. So this will be limit extending to 0. Let us take 9 power x common here. So it will be 8 power x minus 1. So minus 1, let us take common here, 8 power x minus 1. I'm just taking 9 power x from these two. I'm factorizing. So root 2, if I take outside, 1 minus cos x, 2 sine square x by 2, right? 1 minus cos x. So this will be limit extending to 0, 9 power x minus 1, 8 power x minus 1 divided by 2 root 2 sine square x by 4. So we'll make use of standard formula. So p power f of x minus 1. So you multiply and divide by xx. Here you multiply and divide by xx. Here you multiply and divide by x by 4 whole square, x by 4 whole square. So the numerator now becomes x times the numerator becomes limit extending to 0. So this x will become x square. This is log 9. This is log 8. So log 9 log 8 divided by, and this will become 1. So 2 root 2 x square by 16. X square x will get cancelled. So all the x are vanished. So my limit will be 16 by 2 root 2 log e9 log e8. If there is no base, it is e. This is your required limit. Since f is continuous at x equal to 0, we know limiting value is equal to function value. So 16 by 2 root 2 log 9 log 8 has to be equal to the function value at 0, which is a times of log 2 log 3 log 2 log 3. Now these two are equal, find a, but here we have log 9 log 8. So we'll try to bring as log 2 log 3, very simple. So you just write this as log 3 square and you write this as log 2 cube. Now you bring this 2 the front and you bring this 3 here. This will be log 3 log 2 and that is equal to a times of log 2 log 3. So log 2 log 3 log 2 log 3 will get cancelled. So my value of a is 2 will get cancelled. 48 by root 2 is your value of a. So they have given that the function is continuous at 0. They are asking what is the value of a. So you just find limit of this function and equate to the function value at 0. So everything is based on standard formulas only. So if you master standard formulas, very simple all are, right? Very, very simple. We'll move on to problem number 6. Continuity is very simple. You know limits. Problem number 6. F of x is equal to sine of a plus 1x plus sine x divided by x. When x is less than 0, it takes the value c. When x is equal to 0, it takes x plus bx square power 1 by 2 minus x power 1 by 2 divided by b times x power 3 by 2 when x is greater than 0. It looks similar to the fourth problem, I think, or it is same. 1. So instead of tan we have sine. I think more or less same. Okay. Is continuous at x is equal to 0. Find the value of a, b and c, right? So first what we will do is we will find LHL. So limit x tending to 0 minus of f of x. The limit x tending to 0 minus of, to the left of 0 different function, right of 0 different function. So we have to do separately. So it is sine of a1 a. Sine of a1 plus x. So you multiply and divide by a plus 1x, a plus 1x, and then we have plus sine x. So you multiply and divide by xx. Multiply and divide by xx. So whole divided by x. This will become 1. This will become 1. So this will be limit x tending to 0 minus of a plus 1x plus 1 by x. So a plus 2 is your LHL, right? A plus 2 is your LHL. Now you find RHL. So RHL is limit x tending to 0 plus of f of x. So limit x tending to 0 plus of your f of x. Your f of x is root of x plus bx square minus root x divided by b into x root x, right? X root x is x power 3 by 2. So you take a same as previous problem. You take root x common. So you take x common here and then you take x outside the root. It will be 1 plus bx minus 1 divided by bx root x. So you take this 1 by b outside. It will be limit extending to 0 plus of root of 1 plus bx minus 1 by x. Now you take conjugate. So root of 1 plus bx plus 1, root of 1 plus bx plus 1. This is a finite non-zero number. A plus b, a minus b. Remaining this part will be finite non-zero number. So when you apply the limit, what you will have? So this will be 0. So 1 plus 1 is 2. So you take 2 outside. So you take 1 by 2 outside, and already we have 1 by b, limit extending to 0 plus of a plus b, a minus b. So a square minus b square by x. 1 will get cancelled. So bx by b is b. So 1 by 2 is your RHL, right? And what is function value at 0? It is given as c. So since f is continuous, it is given it is continuous at 0. So that means LHL, RHL function value all are equal. So my left hand limit is a plus 2, right hand limit is 1 by 2, and function value is c, right? Function value is c. The function value is c. So that means c takes a value 1 by 2, a takes a value c takes the value 1 by 2, a takes the value 1 by 2 minus 2, right? 1 by 2 minus 2 means minus 3 by 2. See, this is independent of b, because here we are cancelling this b. For any b we can cancel, but make sure that b is not equal to 0. So b can take any real number, but it should not 0. So all real number except 0. If it is 0 means 0, if it is 0, 0 means you cannot cancel, right? So provided this b is non-zero, because b is actually we don't need b itself. B can take any real value, because where RHL is independent of b and LHL is also independent of b. Function value at 0 is also independent of b, right? This is because here we have a plus 2 independent of b. This is also independent of b, but here is b, we are cancelling this, but make sure that b is not equal to 0. So b can take any real value. But if you put any real value, these two is going to get cancelled, right? So a takes a value minus 3 by 2, c takes the value 1 by 2, b can take any real value except 0. B can take any real value except 0, right? Okay. Move on to problem number 7. Examine the continuity of the function given as f of x is equal to minus x square when x is less than or equal to 0, 5x minus 4 when x lies between 0 to 1, 4x square minus 3x when x lies between 1 to 2, 3x plus 4 when x is greater than or equal to 2 at x equal to 0, 1, 2. So we need to check whether f is continuous at 0, 1 and 2. So a little bit lengthy. So first what we will do is we will check continuity. We will check continuity at x equal to 0, right? See, we can do in two ways. That is, you will find LHL at 0. So limit extending to 0 minus of f of x. So limit extending to 0 minus of to the left of 0. What is your function? Minus x square. So when you put limit, it will be 0 only, right? Because minus 0 square. And what is your RHL? Limit extending to 0 plus of f of x. So limit extending to 0 plus to the right of 0, my function is 5x minus 4. So when you apply the limit, it will be minus 4. Now function value at 0. 0 is included where? 0 is included here only. So function value at 0 is 0. And here we see that my LHL is not equal to RHL, right? All three has to be equal. So therefore f is not continuous at x equal to 0 because where LHL RHL are not equal. Limit itself is not exist at that point. Limit should exist and limiting value should be equal to the function value. But what I will do is, in exam point of view, if everything involves algebraic, you can go by definition also. That is, you find LHL. So LHL is limit s tending to 0 f of a minus h. Limit s tending to 0 f of a minus h. So here we need to find continuity at 0, right? Here we need to find continuity at 0. So you put a is equal to 0. So that means we need to find limit s tending to 0 f of 0 minus h. So f of 0 minus h is here, right? So in that you need to find f of minus h. So f of minus h is what? Minus of minus h whole square. So again, when you apply the limit, it is 0 only. See, technically, if you want to go by definition, you can do like this, right? All you can do like this. This all it by definition. So anyway, it is 0 only. Now you find RHL, limit s tending to 0 f of a plus h. Now we are checking continuity at 0. So my a will be 0. The limit s tending to 0 f of 0 plus h. So f of 0 plus is here. So we need to find f of h. So f of h is what? 5h 5h minus 4. When I apply the limit, you'll be getting minus 4. See, same thing only. But I'm just making use of definition. Yeah. And function value at 0 is 0. And same story you have to write. Where LHL is not equal to RHL. Now it is not continuous at 0. Now let us take continuity at 1. I will make use of definition to find continuity hereafter. Continuity at x is equal to 1. So first we will find LHL. So LHL is limit s tending to 0 f of a minus h. So limit s tending to 0 f of 1 minus h. So 1 minus h, where is your function? This is your function, right? To the left of 1, 5x minus 4. So in 5x minus 4, you replace x by 1 minus h because we need f of 1 minus h. So f of x is 5x minus 4. So my 5x minus 4 will be limit s tending to 0, 5 minus 5h minus 4. So when after the limit, it will be 1, right? It will be 1. Now you find RHL at 1. So limit s tending to 0 f of a plus h. So limit s tending to 0 f of 1 plus h will be limit s tending to 0 f of 1 plus h. Where is your function? 1 plus here is your function. So in that, this is your function 4x square minus 3x. In that you replace x by 1 plus h. So 4x square minus 3h. So when you apply the limit, what you will have? The limit s tending to 0 a square plus b square plus 2ab minus 3 minus 3h. So when h is 0, these two will be 0. This will be 0. So it is again equal to 1. Now function value at 1. Function value at 1. 1 is included where? 1 is included here. So 5x minus 4. So 5 times 1 minus 4, which is again 1. So at x is equal to 1, your LHL and RHL and function value all are equal to 1. So it is continuous. It is continuous at x is equal to 1. Right? It is continuous at x is equal to 1. Now similarly, you check the continuity at 2 also, right? 0 it is not continuous, 1 it is continuous. You check continuity at 2. Continuity at x equal to 2. So first you find LHL, the limit extending to 0. You can do any way. You can do this way or that way, anything. Can limit extending to 0. If it is definition means s extending to 0 f of a minus h. If you are doing directly means you can directly write 0 minus 0 plus limit extending to 1 minus limit extending to 1 plus limit extending to 2 minus limit extending to 2 plus, right? This I will go in a that shortcut way, right? I will do this in shortcut way. So LHL is limit extending to 2 minus of f of x. So limit extending to 2 minus. So to the left of 2, what is your f of x? 4x square minus 3x. So directly substitute 2 here. See, don't put minus 2. We are approaching from the left, right? 2. So 4 into 2 square is 4. 3 into 2. So it will be 10, right? Now you find RHL limit extending to 2 plus of f of x. So limit extending to 2 plus to the right to the 2 plus is 3x plus 4. So you put 2 here. So 3 into 2 is 6, 10. Now function value at 2. 2 is included here only. So 3 into 2 plus 4. So which is again 10. So f is continuous. F is continuous at x is equal to 2 because your LHL, RHL and the function value all are equal. Therefore, it is continuous at 2, right? Okay. I'll give you one exercise problem. Problem 8. Nice. We have to check only and item is not real. No. By definition, they are asking you to take the continuity at these 2 points, these 3 points, 0, 1, 2. So by definition, to the left of 2, to the right of 2, and function value of 2. If all are equal, it is continuous now by definition. Okay, I'll give problem assignments separately. So I will not giving homework. I will give you separately. I will do one more problem after that. You just recall the definition of modulus function, right? You just recall the definition of modulus function. How we are defining modulus is it is plus x when x is greater than or equal to 0, minus x when x is less than 0, right? So we know how to find modulus. Whenever you see modulus of minus 4, we will put as plus 4. Whenever you see modulus of minus 10, we will put as plus 10. Whenever you see modulus of 7, you will put 7 as it is, right? If inside quantity is negative, we will make that as positive. Just see the definition. Mod x, if the inside quantity is negative, output is minus of inside quantity. So inside quantity is negative, output is minus of inside quantity. This is how you have to apply the definition. You should not simply put plus 10. You have to put minus of. See, if the inside quantity is positive or 0, you write the inside quantity as it is. If the inside quantity is negative, the output is minus of inside quantity. So minus of inside quantity. So you see modulus of minus 7. Inside quantity is negative. Output is minus of inside quantity. So which is plus 7. You have to understand the definition of mod x correctly, right? And we know how the graph of mod x will be. When x is greater than or equal to 0, it takes x and it is minus x, right? This is a definition of, sorry, this is a graph of y is equal to mod x, right? And this is a continuous function, right? Because I can draw mod x without lifting the hand. I can draw mod without lifting the hand. And what is the definition of mod x minus 2? You just apply the definition. it is x minus 2. If x minus 2 is greater than or equal to 0, instead of x, you replace x minus 2. Minus of x minus 2 if x minus 2 is less than 0. So this will be x minus 2 when x is greater than or equal to 2. This is 2 minus x when x is less than 2. So here the function is breaking at 2. Right? Here the function is breaking at 2. And you can see that at 2 it is equal to 0. To the right of 2, the output is x minus 2. Right? For example, if you put 3, it will be 1. So it will go like this. And to the left of 2, the function takes 2 minus x, and that graph goes like this. So mod x graph is always v, and that v will cut at the zeros of inside quantity, which is 2. Right? Zeros means root of inside quantity. Okay. Now what will be the definition of mod x plus 1? So it will be x plus 1 if x plus 1 is greater than or equal to 0, minus of x plus 1 if x plus 1 is less than 0. So this will be x plus 1 when x is greater than or equal to minus 1, minus x minus 1 when x is less than minus 1. So here the function is breaking at minus 1, right? So when x is greater than minus 1, it takes x plus 1. So you just draw x plus 1 graph, right? Or you just mark some points. So you take 0, 0 takes 1 output. You mark some 2, 2 takes 3. So you put a line. It is a linear. And to the left of 2, it is minus x minus 1. So when you put minus 2 here, what will happen? Minus 2 if you put here, minus of minus 2 will be plus 2. So 2 minus 1. So again it will go like this, right? Again you can see that it is the V, all graph will be V, and it will cut the sharp edge will come at the zeros of inside quantity. These are just elementary level that you come across, right? Modulus function. And you always note that mod x is always continuous, right? Always continuous function because I can draw the whole graph without lifting the hand. That means it is continuous at each of its point. Whatever point you take, your LHL, RHL function value all are equal. So mod is always continuous function, right? Mod is always continuous function. Now suppose if I have a combination of mod, how to discuss the continuity, right? Suppose if I have a combination of mod, how to discuss the continuity, right? How to discuss the continuity for a combination of modulus functions. Okay, we will create a problem, right? We will create a problem. So discuss the problem 8. Discuss the continuity. Discuss the continuity for the function f of x is equal to mod x minus 1 plus mod x minus 2. See, individually both are continuous, but I have a series, right? A series of two mod functions. Now the first thing is we need to check the continuity. If it is continuous, if it is not continuous means at which point it is not continuous. That we need to do. First, what we have to do is we need to break the function. We need to break the function. If I can break the function, problem is very simple. Now, how to break the function is first what you do is you just plot a real line. Just plot a real line. You mark the zeros of this and zeros of this. So 1 and 2. So 1 is the zero of inside quantity and this 2 is the zero of inside quantity. Right? Now you take, now I'm going to redefine my f of x. Right? When x belongs to this interval, when x belongs to this interval, you take some random point. You take some random point. Let us take 0. You substitute 0 here. Inside quantity is positive or negative. You substitute 0 inside quantity is positive or negative. It is negative. The output is minus of x minus 1. That is the definition of modulus, right? If the inside quantity is negative means output is minus of inside quantity. If the inside quantity is positive means output is same as that, right? And similarly, what I'm doing is I'm taking some random point. I'm just checking whether inside quantity is positive or negative. I'm just checking 0 here because 0 is in this interval. So this is in 0 minus 1 is negative. Output is minus of x minus 1. You substitute similarly 0 here. 0 minus 2, it is again negative. So it is minus of x minus 2. Whenever your x belongs to minus infinity to 1. Is this clear? Now 1 to 2. You take some random point. I'm just checking 1.5. 1.5 minus 1. Inside quantity is positive. The output is same as x minus 1. You substitute that random point here. 1.5 minus 2 minus 0.5 negative. So output is minus of x minus 2. When x lies between 1 to 2, right? Now you take some point 3 here. You can take any. If I take 3, 3 minus 1 positive. 3 minus 2 positive. So both are positive. So output is x minus 1, x minus 2. Is this clear? After breaking the problem reduces to very simple, right? What will happen here? Minus x is minus 2x. This is plus 1 plus 2. This is plus 3. When x lies between minus infinity to 1, this x will get cancelled. Minus 1 plus 2, which is constant function. Where x lies between 1 to 2, 2x minus 3 when x lies between 2 to 3. Now they have simply said discuss the continuity. You check continuity at the break point. You check continuity at 1 and you check continuity at 2 because at 1 and 2 only function is breaking. Now continuity at 1. Continuity at x equal to 1. So limit extending to 1 minus of f of x. So limit extending to 1 minus, to the left of 1 my function is minus 2x plus 3. So when you substitute 1, 1 is your LHL. So limit extending to 1 plus of f of x. So limit extending to 1 plus, to the 1 plus your function is constant function. And what about f of 1? F of 1 is again 1. It is continuous at 1. It is continuous at x equal to 1. Now you check continuity. Now you check continuity at x equal to 2. So this means LHL is limit extending to 2 minus of f of x. So limit extending to 2 minus, to the left of 2 again is your constant function. Now limit extending to 2 plus of f of x, which is 2x minus 3 when you put 4 minus 3, and f of 2 is again 1. So it is continuous at 2 also. So this function is continuous at each of its point, right? It is continuous. This function is continuous throughout, right? So whenever your function involves some modulus, first you have to break the function. After that, you can check the continuity. Is this clear? Can I break one more function also? Right? Can I break one more function? For example, let's discuss the continuity of mod x plus 1 plus mod x minus 2 plus mod x plus 3. Can you break this function? First, you put a real line. First, you put a real line, minus infinity, plus infinity. You mark the zeros. Zeros are minus 1, plus 2, and minus 3. So minus 3, minus 1, and plus 2. Now you redefine the function. So minus infinity to minus 3. You take some random point. I'm taking minus 4. Minus 4 plus 1. Inside quantity is negative. So it is minus of x plus 1. You take minus 4. Minus 4 minus 2. Minus 6. Inside quantity is negative. So again it is minus of x minus 2. You take minus 4. Minus 4 plus 3. Again negative. So it is minus of x minus 3. When x lies between minus infinity to minus 3. Now here minus 3 to minus 1. Let us take minus 2.5. Minus 2.5. Minus 2.5 plus 1 negative. minus 2.5 minus 2 negative, minus 2.5 plus 3 positive. So it is plus x plus 3. If instead one is plus, you just write x plus 3. If it is negative, you write minus of x plus 3. When x lies between minus 3 to minus 1. Now 1 to 2, let us take 0. 0 plus 1 positive, 0 minus 2 negative, 0 plus 3 positive. So when x lies between 0 to 2, right? I missed one some part, sorry, minus 1 to 2. Minus 1 to 2. And when this, if you take 3 here, 3 plus 1, 3 minus 2, 3 plus 3, all are positive. Then you can do, right? You check the you check continuity. Check continuity at minus 3, minus 1, and I am doing writing 3. Do this. You check continuity at minus 3, 1, and 2. You find LHL, you find RHL at minus 3, and function value at minus 3. You see whether they are all three are equal. Is it clear, right? So how to break the function involving modulus, right? How to break the function? If you break the function, then it is very easy to. You should see continuity, check continuity. So this one you have to understand. Is it clear up to now? Is it clear, everyone? You always note that, very important note, limit extending to 0 sine 1 by x. This limit will does not exist. This limit does not exist. It oscillates between minus 1 to plus 1. So what will happen here is the graph will be very good, but when it comes to 0, it just flutter. It just flutter between minus 1 to plus 1, and then it will go smoothly. So this sine 1 by x for this function, when x is tending to 0, limit will not exist, right? At x is equal to 0, it oscillates between minus 1 to 1, right? It will flutter between minus 1 and 1. So at when x is 0, the limit does not exist for sine 1 by x, right? When x is 0, the limit does not exist for sine 1 by x. I'll show you. You can see sine 1 by x graph, right? You can see the sine 1 by x graph. When x is tending to 0, it oscillates between minus 1 and 1, right? You can see here. You can see here, right? So this is sine 1 by x graph. The graph will be very smooth. Graph will be very smooth, but when it reaches 0, you can see it just flutter between minus 1 to plus 1, right? Butterfly will flutter, right? Even if you zoom it, you can see you have thick band. That means how that much fast it is fluttering between minus 1 to plus 1 when x is tending to 0, right? Even if you zoom, how much that much fast, unimaginably fast, it will flutter. So for sine 1 by x, when x is tending to 0, limit does not exist. And similarly for cos 1 by x also. Similarly for cos 1 by x also, when x is tending to 0, uh, same thing, right? It will flutter between minus 1 and 1. So both sine 1 by x and cos 1 by x, both sine 1 by x and cos 1 by x will flutter between minus 1 to plus 1, right? Similarly for cos 1 by x also. Okay. Similarly, for cos 1 by x also, limit extending to 0, cos 1 by x also does not exist. It oscillates between -1 to +1, right? Now we know that f is continuous if LHL, RHL function value all are equal, right? Suppose f is discontinuous means what is the case? Your LHL, RHL function value all three are not equal. Then we say it is discontinuous at that point. Now the type of discontinuity can be classified, right? Types of discontinuity. When we say function is discontinuous, your LHL, RHL and function value all are not equal, right? So types of discontinuity. The function is discontinuous. Discontinuous can be classified into four types. There are four types of discontinuity, right? There are four types of discontinuity. The first is called removable discontinuity. Removable discontinuity, right? So when we say a function has removable discontinuity means LHL and RHL both are equal, but these two is not equal to the function value. Is it clear? So anyway, discontinuous only. But this type of discontinuity is called the removable discontinuity. Your LHL, RHL are equal. That means limit existed. Limit extending to a f of x existed, but this is not equal to the function value. All are finite. LHL is finite, RHL is finite, f of a is finite, right? All are finite. All are finite, but it is not equal to f of a. Then that type of discontinuity is called removable discontinuity, right? Now, second discontinuity is called discontinuity of first kind. Discontinuity of first kind. It is also called as jump discontinuity. It is also called as jump discontinuity. LHL exists. Exist means it is finite, right? Limit extending to a, if LHL exists. RHL exists, right? RHL exists, but these two are not equal. These two are not equal. Then we say it is a discontinuity of first kind. See, all are discontinuous only. If it is discontinuous means LHL, RHL function value, all three are not equal. If they are not equal in some special cases, like LHL, RHL are equal, but it is not equal to f of a. At that point, it will have removable discontinuity. Your LHL, RHL both exist, but they are not equal. That means it is discontinuity of first kind. Next is discontinuity of second kind. Discontinuity of second kind. If neither LHL nor RHL exist, the limit itself will not exist. Limit itself will not exist. Limit will not exist means if you apply the limit, it will be like infinity or like that, right? If neither LHL nor LHL exists, then we say it is discontinuity of second kind, right? Fourth is mixed discontinuity, last. Your LHL does not exist, but your RHL exists, or your LHL exists, but your RHL does not exist. If this happens, then we say it is mixed discontinuity, right? Now we will do some problems based on this. We will do some problems based on this. So examine the type of discontinuity. Examine the type of discontinuity. Examine the type of discontinuity for the function f of x is equal to e power 1 by x minus 1 divided by e power 1 by x plus 1 when x is not equal to 0. It takes 0 when x is equal to 0 at x is equal to 0. You see whether x is equal to 0 is continuous or not. If it is not continuous means you tell what type of discontinuity it is. So it is always better to go LHL RHL function value. So limit s tending to 0 f of a minus h. This will be limit s tending to 0 f of a minus h. F of a minus h. So this will be f of 0 minus h. So this will be limit s tending to 0 f of minus h. This will be limit s tending to 0 f of minus h will be e power minus 1 by h minus 1 divided by e power minus 1 by h plus 1, right? So when you apply the limit, this will tend to where? E power minus infinity will tend to 0, right? E power minus infinity will tend to 0. E power 0 will tend to 1. E power x graph is this. This is e power x graph. So when x is tending to minus infinity, your output will be closer to 0. So this will tend to 0, this will tend to 0. So minus 1 by 1, this will tend to minus 1. Now you find RHL. So limit s tending to 0, f of 0 plus h, which is limit s tending to 0, e power 1 by h divided by e power 1 by h plus 1. See, don't say that e power infinity is infinity, right? E power infinity will tend to infinity. Because when x is infinity, this will tend to infinity. See, whenever you have this, you just take e power 1 by h outside. This will be 1 minus 1 by e power 1 by h. And this is you take e power 1 by h again outside. This will be 1 plus 1 divided by e power 1 by h. These two will get cancelled. Now when h is tending to 0, what will happen? This will tend to infinity and 1 by infinity will tend to 0. So this will tend to 1. Yes or no? So when h is tending to 0, this will tend to 1 by infinity. This will tend to 0 because e power when x is tending to 0, 1 by 0 is infinity. E power infinity is infinity. 1 by infinity will tend to 0. So here you see that and function value at 0 is 0. So what discontinuity is? LHL exists, RHL exists, but they are not equal. So it is discontinuity of first kind. Discontinuity of first kind at x is equal to 0. Both exist, but they are not equal, right? Is it clear? So we'll move on to next problem. Examine the type of discontinuity for the function f of x is equal to e power 1 by x minus e power minus 1 by x divided by e power 1 by x plus e power minus 1 by x when x is not equal to 0. It takes 1 when x is 0. You check the type of discontinuity at 0. So first what we'll do is we will find LHL. So limit s tending to 0 f of a minus h. So this is limit s tending to 0 f of minus h. This is e power minus 1 by h. This is e power plus 1 by h. E power minus 1 by h plus e power plus 1 by h, right? Now when h is tending to infinity, this will tend to 0, this will tend to 0, this will tend to infinity by infinity, which is this will tend to overall, it will tend to minus 1. right? Overall it will tend to -1. Limits all about approximation. These two will tend to 0. This will tend to infinity by infinity. I can write this will tend to 1. Right? And similarly, you find RHL, or you can take e power -1 by h common, and then you can do like that also. Or you can take one. You write this as 1 by e power 1 by h. You take LCM. You can do anything. So limit s tending to 0, f of 0 plus h. So the limit s tending to 0, f of 0 plus h, f of h, e power minus 1 by h divided by e power 1 by h plus e power minus 1 by h. This will tend to 0, this will tend to 0, this will tend to infinity by infinity, this will tend to 1. My RHL is 1, so again it is discontinuity of first kind. Discontinuity of first kind, right? Again. Okay. So third question. So f of x is sine 1 by x when x is f of x equal to e power 1 by x when x is not equal to 0, it takes 0 when x is 0. But, so you check what kind of discontinuity the function has at x equal to 0. So you find LHL, so limit x tending to 0 minus of f of x. So limit x tending to 0 minus, where f of x is e power 1 by x. No. We'll go by definition. Limit s tending to 0, f of a minus h. So limit s tending to 0, f of minus h. So this is limit s tending to 0, e power minus 1 by h. So this will tend to e power minus infinity. This will tend to 0. So this is limit s tending to 0, f of or minus infinity only, right? So this is f of 0 plus h, f of h, f of e power 1 by h. This will tend to e power infinity. This will tend to infinity. This does not exist, right? Does not exist. So your LHL exists and finite. RHL does not exist. That means it has a mixed discontinuity, right? Discontinuity of second kind. Just a minute. What is the definition of discontinuity of second kind? Discontinuity of second kind if neither limit x into m non, right? Then is of second kind. It has mixed discontinuity, right? It has mixed discontinuity. So these are the small subtopics about classification of discontinuity, right? So continuity is over. Very simple. So if you want to check continuity at some point, you just find LHL at 0, RHL at 0, function value at 0. If all are equal, it is continuous. If all are equal, then it is continuous. If they are not equal in some other way, it is discontinuous. That discontinuity can be classified into 4 types, right? So removable means both LHL and RHL are equal, but it is not equal to the function value, right? And discontinuity of first kind means LHL and RHL both exist, but they are not equal. Okay. Is there any doubt? In our previous notes, sir, discontinuity of second kind is if neither LHL or RHL does not exist. But here you like here LHL exists, RHL doesn't. நீங்க முன்னாடி சொன்னீங்க சார் differential. Okay. அதுல வந்து என்ன சொல்லிருக்கீங்கன்னா வந்து neither LHL nor RHL does not exist அப்படின்னு சொல்லிருக்கீங்க. இங்க வந்து neither LHL nor RHL exists. Actually, what they have said is, I'll just read the definition of from the book. Discontinuity of second kind. If neither limit extending to a minus f of x nor limit extending to a plus f of x exists, then f is said to have a discontinuity of second kind at a. If neither limit extending to a minus, that is your LHL, nor limit extending to a plus, that is your RHL, both limit nor exist, both your LHL RHL does not exist, then f is said to have a discontinuity of second kind. Further, f is said to have a discontinuity of second kind from the left if your LHL does not exist. Okay. Got it. See, discontinuity of second kind means limit extending to a minus f of x does not exist, and limit extending to a if the see, no problem. We will fix this. See, actually, discontinuity of second kind they have classified into two things. How they have classified is discontinuity of second kind from the left, discontinuity of second kind from the right. If limit extending to a, f is said to have a discontinuity of second kind from the left if your LHL does not exist, but your RHL exists and function value also exists. F is said to have a discontinuity of second kind from the right if your RHL does not exist. Again, they are classified into two things. How they are classified is discontinuity of second kind from the left. That means limit extending to, that is your LHL does not exist. Actually, we don't need to confuse so much, but you just only do this, right? See, mixed discontinuity is also a special case of discontinuity of second kind, right? So we don't need to bother too much. Let us don't let us fix this. Discontinuity of second kind, neither of LHL nor XL exists. Mixed discontinuity of second kind. Actually, in the book they have given this. They have given this as discontinuity of second, they have given this as discontinuity, they have given this as discontinuity of second kind from right, they have given this as answer. Because your RHL does not exist, but LHL exists. If LHL exists, RHL does not exist, it is discontinuity of second kind from the left, which is same as mixed discontinuity. If function f as a discontinuity of second kind on one side of A, yes. See, mixed discontinuity, special case is discontinuity of second kind, right? That is not a problem. You just take this as two, case one, case two. Discontinuity of second kind. So you, for exam point of view, you just avoid this fourth. You only finish in first three. Discontinuity of second kind from left. That means your LHL does not exist, but RHL exists. Case two, discontinuity of second kind from right if your RHL does not exist. If both does not exist, you simply say this discontinuity of second kind, right? Okay. Okay, so continuity, I'll send you some practice problem for continuity, right? So we did 3, 4, 5, 6. Okay, so we'll stop here. We'll have a 10 minutes break. After that, we will start differentiability, right? So we'll have a break. We'll start after 10 minutes differentiability. So we'll resume. Okay, so we'll start differentiability at a point, right? So when a function is differentiable at a point, we know when the function is continuous at that point. So my LHL, RHL, function value, all three are equal means we say f is continuous at that point. Now similarly, we will define what is when we say a function is differentiable at a point. When we say a function is differentiable at a point, right? So differentiability at a point. See, let us consider a graph y is equal to f of x. Let us consider a graph y is equal to f of x, right? Now let us take a point A, and this is my output f of A. Now what I'm going to do is, at this point, I'm going to draw a tangent line. At this point, I'm going to draw a tangent line, right? At this point, I'm going to draw a tangent line. The slope of this tangent line, right? This is a tangent line I'm drawing. You know what is tangent line, right? A line that touches the curve at only this point. The slope of this tangent line, right? The slope of the tangent line through f of a, right? At f of a, that will be some number. Slope, no. I'm going to call that number as f dash of a. I'm going to call that number as f dash of a, right? So f dash of a is nothing but you have a, you have f of a. At f of a, you draw the tangent line to the curve. The slope of that tangent line is a number. That number I'm going to call as f dash of a. So very simple, right? A is a point, f of a is the output, and for that output you draw tangent line to the curve. The slope of that tangent line is your f dash of a. Now, how to find f dash of a? That is a question. How to find the slope of this tangent line? The slope of this tangent line is nothing but your f dash of a. So, how to find f dash of a? That is the next question, right? In order to find the slope, what is this coordinate? This coordinate is a comma f of a, right? This coordinate is a comma f of a. So we know one point in the line. We know one point in the line. We know one coordinate in the line, which is a comma f of a. How to find the slope of a line? We can find in many ways. Tan theta. If I know 2 point, I can find the slope using y2 minus y1 divided by x2 minus x1, right? But here the thing is, in this line, we know only one point, which is a comma f of a. I don't know one more coordinate. So I cannot find the slope of this line, right? I know one coordinate, which is a comma f of a, but I don't know the other coordinate. I don't know the other coordinate in the line. If I know one more coordinate in this line, then I can use y2 minus y1 divided by x2 minus x1 to get the slope. Now, how to find the slope? The next thing. Now, what we'll do is, let us assume s to be greater than 0. Let us take h to the right of a. Let us take s to the right of a. Let this distance h, then this point will be a plus h, right? Now, output is f of a plus h. Now, this point is f of a plus h, and we know this coordinate, right? This coordinate is what? A plus h comma f of a plus h, right? This is my coordinate of a plus h comma f of a plus h, right? We have a curve y is equal to f of x. At a, this is my f of a. At f of a, we are drawing the tangent line. The slope of this tangent line is f dash of a. How to find f dash of a? I don't know. If I know 2 point in the line, I can find slope using y2 minus y1 divided by x2 minus x1, but I don't know two coordinates. I know one coordinate as a comma f of a. So what I'm doing here is I'm taking a positive quantity h to the right of a, right? At h greater than 0, I'm forming a plus h to the right of a. Now what I'm going to do is I'm going to connect this point and this point. So whenever I'm connecting 2 points in the curve, that line is called the secant line, right? That line is called secant line or chord. You can call anything. So whenever if I connect any 2 points in the curve, then that line is called the secant line, right? The line is the secant line. So I'm going to connect these two lines. I'm going to connect these two lines. So I'm going to connect these two lines, right? This red line is called the secant line. This red line is called the secant line. I can find the slope of secant line, right? I can find the slope of secant line, yes or no? Because I know two coordinates. I can find the slope of secant line. In secant line, one coordinate is a comma f of a, that is also a coordinate of tangent line. Another coordinate is a plus h comma f of a plus h. Now what is slope of secant line? So y2 minus y1 divided by x2 minus x1, right? A plus h comma f of a plus h is one coordinate, a comma f of a is another coordinate. So y2 minus y1 divided by x2 minus x1. So the slope of secant line is f of a plus h minus f of a divided by h, right? We need to find slope of tangent line, but we have found slope of secant line, right? We have found slope of secant line. Now how to find slope of tangent line? Very simple. What happens if this a plus h is becoming closer, 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 closer to a? Then the secant line will approach tangent line. Can you able to visualize? See, for example, if my h is very, 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 very small, then a plus h will be here and f of a plus h will be here. right? F of f dash h will be here. Now you connect these two lines, it will be a secant line. You can see how closer it is to tangent line, right? So this red line can be moved to yellow line approximately, like this red line can be make we can make that red line to be an yellow line, very very closer to yellow line. If this h is very 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 small, who are listening, is it, can you follow? If this h is very 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 small, then the secant line will tend to tangent line, right? If this gap is very very small, then we can always form a secant line, right? Because secant line means you have to connect any two point on the curve. A plus h will be always a point on the curve only if h is not equal to 0, right? If h is equal to 0, then a and a plus h both are same. Okay. Now the slope of tangent line can be found if the limiting value of h is very 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 closer to 0 to the slope of secant line. So in the slope of secant line, you make s to be very 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 small, then the red line will move to yellow line. So that means I'm going to call this as r of f dash of a. Why r? Because I have taken s to the right of a. So r of f dash of a is limit s tending to 0 f of a plus h minus f of a divided by h. This is called right hand derivative. This is called right hand derivative for the function f of x at x is equal to a, right? So very simple. You have a, find f of a. At f of a, you draw the tangent line. The slope is your f dash of a. I'm finding slope to the right of, I'm taking a point s to the right of a, and then I'm making a red line to be an yellow line from the right. So that is called right hand derivative. Similarly, you can find left hand derivative. You form a minus h, and this will be my f of a minus h, and this coordinate is a minus h comma f of a minus h. Now you connect these two lines, you'll be getting a secant line. Find the slope y2 minus y1 by x2 minus x1. You put s tending to 0, you will get slope of tangent line. So your L of f dash of a will be limit s tending to 0 f of a minus h minus f of a divided by minus h. Right? This is a formula for left hand derivative. This you can easily derive, right? This point is what? This point is a minus h comma f of a minus h, and another point is a comma f of a. So y2 minus y1 divided by x2 minus x1. So these two will get cancelled. So we'll have minus h in the bottom. So this is called a left hand derivative of the function at the point a. We say f is differentiable at x is equal to a if left hand derivative is equal to right hand derivative. That's it. So the only thing is you have to find limit for this function. That will be your L of f dash of a. You have to find limit for this function. That will be your R of f dash of a. You see whether they are both are equal and also they are finite. If this happens, then we say f is differentiable at a. So differentiability at a point is nothing but slope of tangent line at the point. Differentiability at a point is nothing but slope of tangent line at that point, right? So in order to prove f is differentiable at some point, you have to find L of f dash of a, R of f dash of a. You see that both are equal. Note, whenever your function has sharp edge, whenever f has sharp edge at some point, at that point f is not differentiable. Whenever you have sharp edge, for example, the function is like this, right? You can see here it has sharp edge, sharp edge, sharp edge. So at these points, the function is not differentiable. Why? Because at these points, there is no unique tangent line. You can draw infinitely many tangent lines at that point. There has to be unique tangent and that slope of the tangent line is f dash of a. But if you have a sharp edge means you can draw infinitely many tangents at that point. For different tangent line, you will have different slopes. So in that case, it is not differentiable. We say f is differentiable. At that point, there has to be only one unique tangent, and if you find the slope from the right and from the left, both has to be equal. That is the definition of derivative at a point, right? So whenever you have sharp edge, it is not differentiable. Continuity at a point, does continuity at a point does not imply differentiability at a point. If a function is continuous at some point, it may or may not differentiable at that point. For example, you consider mod x. Mod x is continuous everywhere, right? Mod x is continuous everywhere. But mod x is not differentiable at 0 because at 0 it has sharp edge. Yes or no? At 0 it has sharp edge. So it is continuous at 0, but it is not differentiable at 0, right? It is continuous at x equal to 0, but not differentiable at x equal to 0. So continuity at a point does not imply differentiability at a point. If a function is differentiable at a point, obviously it will be continuous at that point. So differentiability implies continuity. The function is differentiable at a point, it will be continuous at that point, right? If the function is not continuous, obviously it will be not differentiable also. Because you cannot form f of a itself if it is not continuous. For f of a only you have to draw the tangent plane, right? So these four notes are important. And so how to check continuity? Sorry, how to check differentiability at a point? You find L of f dash of a, you find R of f dash of a to see whether they are equal. If they are equal, you say it is differentiable. If not, you say it is not differentiable. Right? The problem. Check the continuity and differentiability for the function f of x is equal to x into sine 1 by x when x is not equal to 0, 0 when x is 0, at x is equal to 0. Now we need to check whether the function is continuous at 0 and differentiable at 0, right? So we'll check continuity at 0. So that is, we need to check whether limit x tending to 0 of f of x is equal to f of 0. If this happens, we say it is continuous at 0. Now, limit x tending to 0 of f of x. This is limit x tending to 0 of, what is f of x? X into sine 1 by x. Remember, this limit is 0. This limit does not exist. A quantity that oscillates between -1 to +1. But since we have 0 into something, the whole thing will be 0. If you have only sine 1 by x, limit does not exist. But we have 0 into does not exist. It will be 0 only. And what about f of 0? It is 0, right? So therefore, f is continuous. So f is continuous at x is equal to 0. F is continuous at x is equal to 0. Now we will see differentiability at x is equal to 0. So first what we will do, we will find R of f dash of a and then we will find L of f dash of a. So R of f dash of a is limit s tending to 0 f of a plus h minus f of a divided by h. Here my a is 0 because we are checking at 0. So this is limit s tending to 0 f of 0 plus h minus f of 0 by h. So this is limit s tending to 0 f of h minus f of 0 by h. So this is limit s tending to 0. What is f of h? H into sine 1 by h. F of 0 is 0 divided by h. So this is limit s tending to 0 sine 1 by h does not exist because we have only sine 1 by h here. This will get cancelled. So your R itself does not exist. There is no way, there is no need to find L of f dash of A. Both should exist and both should finite. Then only it is differentiable at A. So therefore, f is not differentiable at x is equal to 0. It is continuous at 0, but it is not differentiable at 0. I given you an example, right? Continuity at a point does not imply differentiability, right? Now, what happens if I change the question to x square sine 1 by x? What happens? What if I'm asking you one question? What if the function is x square sine 1 by x when x is not equal to 0, 0 when x is equal to 0? Obviously, it is continuous because 0 square into a quantity that oscillates between minus 1 and 1. So obviously, it is continuous. Is it differentiable? Is it differentiable? First, you find r of f dash of 0, limit s tending to 0, f of 0 plus h minus f of 0 by h. So limit s tending to 0, f of 0 plus h square sine 1 by h, f of 0 is 0 divided by h. So this will be limit s tending to 0, h into sine 1 by h again. One h will get cancelled. This will be 0. So if I change this to be x square, my r of f dash of 0 is 0. And what is my L of f dash of 0? Limit s tending to 0, f of 0 minus h minus f of 0 by minus h. So limit s tending to 0, f of minus h minus 0 by minus h. And what about f of minus h? Minus h whole square sine of minus 1 by h by h. This is an odd function. So this is limit s tending to 0 minus h into sine 1 by h. Again it is 0. Right? That is you have to write like 0 into a quantity that oscillates between minus 1 to 1. So if you change this as x square, it is continuous and as well as it is differentiable at x equal to 0. Right? What about only sine 1 by x? That is, you don't even have x. Only if you have sine 1 by x, it is not continuous as well as not differentiable at 0 because limit itself will not exist. No, if it is, there is no x here. So very simple. If you want to check the continuity, if you want to check the differentiability, what you have to do? You just have to find L of f dash of a, R of f dash of a. So we will move on to next problem. Very simple problem. Examine the differentiability at x is equal to 1 for the function f of x is equal to x square minus 1 when x is greater than or equal to 1, 1 minus x when x is less than 1. So first what we will do is we will find r of f dash of 1. We need to check differentiability at 1. So limit s tending to 0, f of 1 plus h minus f of 1 by h. So limit s tending to 0. What is f of 1 plus h? 1 plus h is here. So this is 1 plus h whole square minus 1. In this function, you have to replace x by 1 plus h. Minus, what is f of 1? 1 is again here. So f of 1 is 0 divided by h. This limit s tending to 0, 1 plus h square plus 2h minus 1 by h. These two will get cancelled. Limit s tending to 0, you take h outside. These two will get cancelled. So 2 is my R of f dash of 1. Now similarly, you find L of f dash of 1. So limit s tending to 0, f of 1 minus h minus f of 1 by h. So limit s tending to 0, f of 1 minus h. This is my function. So 1 minus x, f of 1 is 0 divided by h. This limit s tending to 0, 1 minus 1 plus h by h. This will be 1 of 1 to minus h. This is minus 1, right? You see that R of f dash of 1 is not equal to L of f dash of 1. So therefore, f is not differentiable at x is equal to 1. So very simple. You just have to make use of this formula. You find limit. You know how to find limit. You just see whether they are equal or not, right? So this is very limited topic. Very simple topic. Okay. So we'll move on to the final problem, and then we'll wind off. F of x is equal to x square plus 3x plus a if x is less than or equal to 1, bx plus 2 if x is greater than 1 is differentiable everywhere. Find a and b. See, we have already found a and b using that continuity problem, right? Here it is differentiable at everywhere. That means it's differentiable at 1. 1 is a point, it is breaking, right? So f is differentiable at x is equal to 1. That implies f is also continuous at x is equal to 1, right? I'll give you one shortcut to find L of f dash and R of f dash if it is differentiable, right? If it is differentiable, so L of f dash of 1 will be equal to R of f dash of 1. I'll give you one shortcut to find L of f dash of 1. So how to find L of f dash of 1? You can go by definition. I'll give you one shortcut. If it is differentiable only, it will work. If you want to check differentiability, you have to make us a definition only. Suppose in the question it is given it is differentiable, find some unknowns means you can make use of this. So what you have to do is to the left, what is the left hand derivative of, we need to find L of f dash of 1. What is the function to the left of 1? This is a function to the left of 1. So you differentiate that function to the left of 1 and then you put x is equal to 1 because at 1 we are checking. It's a shortcut. To the left of 1 function you differentiate and then you put x is equal to 1. This will be what? 2x plus 3. So 5 will be my L of f dash of 1. See how fast I did. If you want to find R of f dash of 1, you differentiate right hand side function of 1, which is bx plus 2, and then you put x is equal to 1. So this is b, right? So that means since these two are equal, L of that means b has to be equal to 5. See how fast I did, very simply. That means b has to be equal to 5. If it is differentiable means obviously my L of f dash has to be equal to R of f dash. If you want to find very easily shortcut, you differentiate the left hand side function of 1 and you put x equal to 1 because you're checking at 1. If you want to find L of f dash of 2 means you differentiate left hand side function of 2 and then you put x equal to 2. So b is 5. Now it is also continuous. Now it is also continuous. So my LHL, RHL function value at 1 all are equal. It is continuous at 1 also, right? So that means limit x tending to 1 minus of f of x. So limit x tending to 1 minus x square plus 3x plus a. Now when you put x tending to 1, it will be 4 plus a. So 4 plus a is my LHL. So limit x tending to 1 plus of f of x. So limit x tending to 1 plus of f of x is bx plus 2. When you put limit, it will be b plus 2. So obviously my LHL and RHL has to be equal because it is continuous. So that means 4 plus a has to be equal to b plus 2. And we know b is 5. That means a is 7 minus 4. So a is 3. So a is 3, b is 5. So we have already did some problems like continuity at 1. Only we are make use of, we made use of this thing. Now we are also making use of L of f dash of 1 is equal to R of f dash of 1. For that you make use of the shortcut, right? So that's it. So I'll stop here. So the next class we will discuss more on mean value theorems, Rolle's theorem, Lagrange's theorem. Then you will have more idea, right? So limits, continuity, differentiability, all are at a point only we are checking. So very simple. I'll give you a lot of practice questions, assignment questions in the WhatsApp group, right? So thank you. We'll see you in the next class. Thank you. Bye.